I am just fine. I just started.
Here we go. So, we have 4 different problems. You will need to know how to distribute and combine like terms. Okay, I'm going to show you an example of what we're going to end up getting to that's going to scare you, but it shouldn't. So, first off, we have 3x's plus 5x's. This is an adding and subtracting problem. At no place does it say we're going to multiply them. So make sure that you do what it says. 3x plus 5x is 8x. The negative 4 comes down. Nice and easy. This, we have negative 2 that's smack dab up against the parentheses. We have to multiply that negative 2. That's what is distributing. And when we distribute, we multiply. 5x didn't get touched, it comes down. Negative 2 times 3x is negative 6x. Negative 2 times negative 4 is positive 8. Now I have 5x minus 6x, which is negative 1x plus 8. Okay? Those we've done. We're still going to continue to do those. For those of you who were here yesterday, I saw a lot of great work. Okay? Even yesterday, I saw that you guys were really getting this. First step in any equation, and this is super important, is to find the balance point. The balance point is always the equal sign. I'm trying to get x by itself, which means I need to move this 15. 15 plus x. Olivia, what was the inverse of this positive 15?
Division.
Subtraction.
Subtraction. We subtract 15 from both sides. This is the additive inverse. 15 minus 15 is 0. X comes down. 0 plus x is x. That's the additive identity. 27 minus 15 is 12. And a lot of you had that, which is great. Number 4 was a little bit trickier, only because it was on the other side. This is the x that I'm trying to isolate. We have a minus 24. Maris, what was the inverse of minus? That's subtraction.
Plus.
Yeah, we're going to add 24. Mr. H, why? Because this is a seesaw. What we do to one side, we have to do to the other. Negative 24 plus 24 is 0. That's the additive inverse. X is left over. This gives me 42. What questions do we have on one-step equations? So we've only done half of the one step. Go ahead and get out your homework, please. It was numbers 1 through 10, 23, 25, 26, and 28. Even though some of us had a little bit of trouble not naming names. Good. Oh, not 28, 30. 23, 25, 26, and 30. Not 28, sorry. Nice. Let me put the scores in before I forget, then we'll go over these and I will gladly show any of them.
Wait, what problems did you say?
1 through 10, 23, 25, 26. 1 through 10. No, 1 through 10. And
1
then-
through 20. Number 23, number 25, number 26, and 30. Okay, you have to show work. Here we go. So, number 1 is V equaling 18. Number 2, P equals 5. Number 3, B equals 8. Number 4, N equals 6. Questions on the first 4. Okay. Number 5, M equals negative 16. Number 6, X equals 20. Number 7, M equals negative 4. 8, P equals 1. Questions on 5 through 8. Number 9, V equals negative 12. And number 10, N equals negative 7.
What was 8?
8 was P equaling 1. Okay, 23, X equals 1. 25, X equals negative 2. 26, N equals negative 2. And 30, M equals negative 10. Questions? Any that we need to see? Okay. So we are now in day 2. We are spending 2 days on one-step equations. We will spend 2 days on two-step equations. And then on Friday, you will have a quiz on 1- and 2-step equations. Friday, you will have a quiz. Listen again. Friday, you will have a quiz. Okay, here we go. What now? Well, you did. What'd you
I
say?
said I have 3 tests Friday.
Do you?
Yeah.
Okay. Then maybe I will move the quiz. Okay. So, yesterday we talked about inverse operations. So this is where we're starting our notes. You're going to want to copy this down. So, first off, inverse means opposite. The opposite of addition, we said, was subtraction. The opposite of subtraction was addition. Okay, that's all we did yesterday. Those were the only 2 inverse operations that we used yesterday, were addition and subtraction. Today, we're going to talk about multiplication, which we said the inverse was what? What's the inverse operation of multiplication? We did this yesterday, so very good, Holly. Division. And then, if we have division, what's going to be the inverse? Multiplication. Okay. The very first one that we see is a little bit confusing because you're going to try to add, and I assure you that is wrong. So here's example 1. Negative 12x equals 36. Negative 12x equals 36. Here's what I want you to do always. What's the very first step? Always. Find the balance point. Always, 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 always. Then I want you to read the problem. And I want you to read it mathematically. I'm not going to say negative 12x. That doesn't tell me anything. What does it mean when I have a number next to a variable? Does it mean add, subtract, multiply, or divide? Marissa, we're going to do notes now, not work on our homework. Thanks. No, it doesn't say negative 12 plus x, so it's not add. What does it mean when we have negative 12, which is our coefficient, next to a variable?
Multiply.
Yeah, it means multiplication.
What?
So this says negative 12 times x. What's the inverse of negative 12 multiplied by x? What's the inverse of multiplication? Division. So we divide by negative 12. But what we do to one side, we do to the other. Negative 12 divided by negative 12 is 1. If it helps you to say, hey, Mr. H, I'm just canceling it. Cool. That's not what's happening. It's actually the multiplicative inverse. It equals 1. But if you need to say to yourself, I cancel it, cool. It's still x. Then we do the other side. 36 divided by negative 12 is negative 3. We're going to do a bunch of these. V equals 80. Okay, first step, what do we do?
You divide 5.
Not yet. We always want to find the balance point. And I'll show you an example why that's going to be important in a little bit. How would I say 5v mathematically? What does it mean when I have a number smack dab up against the variable? Multiply. 5 multiplied by v. What's the inverse of multiplication? Division. So we divide both sides by 5. 5 divided by 5 is 1. 1 what? 1v. The v is all that's left over. So now we get our calculator and we do 80 divided by 5. What's 80 divided by 5? 16. Okay, let's do another one. And this is probably the trickiest one of all. Negative x equals 17. This is definitely the trickiest of them all. The goal of any equation is to isolate the variable. To have one x, one v, one b, whatever it is, one of them. Right now, we have a negative x. How many negative x's are there? So really this is negative 1x. So I find my balance point. When we have a coefficient next to a variable, it means multiplication. So if it's multiplying, what do we have to do as an inverse? Divide. We're going to divide both sides by -1. Why? Because a negative divided by a negative is positive, and that leaves us with a positive 1x. 17 divided by -1 is -17. Okay, still with me there. So far, all we've done was read it and say this is really -12 times x. And this is going to be the one, if you miss one, it's going to be something like that, because you're going to try to add 12. When there's a number next to a variable, it means multiplication. Number next to a variable means multiplication. Number next to a variable means multiplication. Well, what if we have something like this? So now I have a fraction. We know every fraction is a division problem. So I find my balance point. How would I say this side over here? How would I say this left side right here? X divided by 3. So the inverse of division is multiply. We multiply by the number and its sign. Notice how I put it catty corner, okay? Really what's happening is we're saying 3 times x divided by 3. 3 divided by 3 is 1. If that's confusing, look, all you have to know is those are gone. When we multiply a division problem, we can get rid of the numerator and the denominator. We're left over with x. But if I multiply by 3 on this side, what do I have to do on this side? Multiply by 3. -12 times 3 is -36. And I know I'm just throwing example after example. You need to see them so that you know what steps to take. Okay, here's example 5. 18 equals x divided by 5. Oh, I shouldn't have said that. 18 equals x, a bar, and 5. First step, we find the balance point. Pop, pop, pop. Okay, we find the balance point. I told you this is x divided by 5. What's the inverse of division?
Multiplication.
Multiplication. What are we going to multiply both sides by?
5.
By 5. And again, I put the 5 up in the top. I put the 5 here. The 5s are going to cross out because really it becomes 1. This is 5 divided by 5. The x comes down. 18 times 5 is 0. Carry the 4. Is that 90?
Yes.
Yay! Questions there?
No.
Okay. We have 2 more examples to do. It will be a little bit confusing. We have -x divided by 6 equals 2. As soon as you see a negative with that fraction, that negative is going to go with the denominator. So this is really saying x divided by -6. X divided by -6. So I find my balance point. If it's division, the inverse is to multiply. Well, what are we going to multiply by?
-6.
The -6. But we do that to both sides. X comes down. 2 times -6 is -12. Have I lost anybody? Okay, all we're doing is either multiplying or dividing. You've only got 4 inverse operations. So if you read the problem, it will tell you which one to do. Last but not least, this is example 7. 12 equals negative x divided by 4. So we find our balance point. We read negative x divided by 4. That goes with the denominator, which is negative 4. We multiply both sides by negative 4. We multiply both sides by negative 4. X comes down, negative 48. What questions do you have? You must show me work. If all you do is give me an answer like this, I am not giving you credit. I need to see the balance point, and I need to see the inverse operations. Does everybody understand that? So your homework is the rest of the sheet. You did 14 questions. Now you're finishing it. So some of you did a couple extra yesterday, which is fine. You are going to finish it. You have right now about 15, 20 minutes. There is no reason that you should not finish this homework. I'll be glad to help you. I will check all of them if you'd like me to, but you need to show the balance point. Show the inverse operations, have your answer. Questions?
May I please get a copy of the